Hello and welcome to the rest of our video notes for lesson 4.5. That's why it says 4.5 continued. We're going to pick up where we left off, and that was talking about the concept of CPCTC. And so let's just pretend for a second that I have these two triangles, and let's say we were given this information. Let's say we were given that AC was congruent to DF, and CB was congruent to FE, and AB was congruent to DE. Then we know the triangles are congruent by side, side, side. But what if then we were asked to prove that angle B was congruent to angle E? Well, since I know nothing about any of the other angles, I can't just prove the angles are congruent any other way. But since I know the triangles are congruent by side, 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 remember this symbol means therefore, angle B is congruent to angle E, because those are in the corresponding place of the two triangles, by CPCTC, which stands for corresponding parts of congruent triangles are congruent. And that's how those individual parts. I could also use that same reason to say A is congruent to D, or say that C is congruent to F, or let's say I was talking about their areas. I could say the area of triangle ABC is congruent to the area of DEF, or equal, because corresponding parts of congruent triangles are congruent. And so I could say their areas are equal also. So remember that we talked about CPCTC at the end of the previous lesson. Here's just a review of that. Remember, SSS, SAS, ASA, AAS, and HL all use corresponding parts to prove that triangles are congruent. This concept of CPCTC uses the fact that triangles are congruent to prove that corresponding parts are congruent. Alright, so this is how we're going to use CPCTC. We're given all this information about these two triangles, and we want to prove that AB is congruent to DC, and we're going to use triangle congruence to do that. Now look at the given information. We're told that AB is perpendicular to BC, and DC is perpendicular to BC. That creates these overlapping right triangles. So I could potentially use hypotenuse leg if I knew the right information. And we're told that AC is congruent to BD, and AC is the hypotenuse of triangle ABC, BD is the hypotenuse of triangle DCB, so the hypotenuses are congruent. We just need to prove that legs are congruent. Well, you'll notice they both share a leg in the segment BC, so here's how we go through the proof. We state our first two givens, the ones that are very similarly worded, as one given statement. That fact alone tells us that ABC and DCB are right triangles. Okay, because of our definition of right triangles and definition of perpendicular, we can go ahead and just say definition of right triangles makes these right triangles. Then we can go back and say our other given, that AC is congruent to BD. Remember, those are each a hypotenuse of their respective triangle. And we know that BC, the shared side, is a leg of both triangles, so it's congruent to itself by the reflexive property. So there's your leg, and because we've already said they're right triangles, we can use hypotenuse leg to prove that triangle ABC is congruent to triangle DCB. Since the triangles are congruent, they're parts that are corresponding, AB and DC, are congruent. So we say that AB is congruent to DC because corresponding parts of congruent triangles are congruent. The short way of writing that is CPCTC. Alright, we're going to do one more proof using that corresponding parts of congruent triangles are congruent. CPCTC. The corresponding parts we're going to match up are PQ and PS. We want to prove that these two parts are congruent. The only way to do that is to first prove that the triangles are congruent. So let's look at what we're given. We are given that this segment PR going through the middle bisects angles QPS, so we have congruent angles there, and QRS, congruent angles there. Remember, anytime two triangles share a side, that pair of sides are congruent by the reflexive property. So if you'll notice, we have a pair of congruent angles, another pair of congruent angles, and the included sides are congruent, so these triangles should be congruent by angle, side, angle. And so we're going to go through our proof and do that. And here's what we should get. We are given that PR bisects angle QPS and QRS, so we know that angle QPR is congruent to angle SPR by definition of angle bisector. And we're going to come back to the other side of the triangles in just a second, but we also know that PR is congruent to itself by the reflexive property of congruence. And now we want to go back and again state that angle QRP is congruent to angle SRP, again by the definition of angle bisector. And so what we've shown is a pair of angles are congruent here, the included side is congruent to the other included side, and then that other pair of angles are congruent. And the reason I wrote this in this order is just so we can easily see that angle, side, angle match up to that correct order. Because of these three steps, we can say that triangle QPR is congruent to triangle SPR by angle, side, angle. And since the triangles are congruent, their corresponding parts are congruent. So I can say PQ is congruent to PS, and the reason is CPCTC. So we'll do some more proofs in class over this this concept here, but again, if you're trying to prove that just individual parts are congruent, you know you're going to have to prove that triangles are congruent first by one of our 5 congruence theorems. Then we can prove that the individual parts are congruent by CPCTC. All right, if you have any questions, make sure we talk about them in class, and we will go from there.